Hey, welcome back to the Build It Basement. Today we're working on our Voron 0.1 print head. So really rounding a corner, coming towards the end of this build. This is kind of like the epic point where we really start to see this being as a printer. Only thing gonna be left after this is pretty much the functional electronics and then an enclosure if we want one. We don't even need an enclosure if we don't want one. But let's jump right into it and get some exciting stuff. Zoomed in today. We are zoomed in today and we're going to set Mr. Voron 0 aside. I don't think we'll do much with him. And box of goodies. Yeah. So in our box of goodies today, what we have, whoops, that's not what I wanted right there. What we have are not only the parts for our build, but some extra special, to me at least, maybe to you, additional parts. Some things I ordered from E3D that came a little while ago, and I've been kind of holding on to them until this portion of the build. So let's see what we got here. Let's pull out the plastic parts, our printed parts. We're gonna need those too. But lo and behold, we have our REVO VORON. So at one point in time, I was actually going to build this with a utilizing a print I found for a Voron for REVO Micro. So with a nut in there to put in there, but it takes so long to build everything that help us all, right? That there was enough time for the people over at E3D to come out with the REVO Voron, and that's what we're going to use in this build. So I'm pretty excited about that. It's a super small, super lightweight print head, and it's going to match up with this printer for super speed, right? So here we go. Let's jump into it. Bada boom, bada bing. What do we see? All right, so here's our print head. It is known as the afterburner, or the mini afterburner, I should say. I don't even know why I call it mini afterburner. It looks absolutely, for the most part, I guess marginally like the afterburner, but not by much. The afterburner is being preceded, put out the pasture by the stealth burner that hasn't, as far as I know, been 100% vetted, but the beta on that is closed out, so maybe we'll see a mini stealth burner coming at some point. So component prep, starting off here, we got some heat set inserts that we need to put in, so I have to gather those up real quick. We're gonna need 3 in this particular step, so get 3 of those. Jump back into my camera. Yeah, we look a little foggy there. Let me see if I can get that zoom a little, or that focus a little bit better. There we go. All right, so we're zoomed in today, hopefully for a better viewing experience. So okay, so first things first, we have this piece right here, printed piece, very nice piece, printed on the Voron 2.4, nothing wrong with that. There is a flat surface here, and there is a surface on the back side, I'm gonna call it the back side, that has some protrusions, 2 here and this larger one there. So this is going to sit with the protrusions facing downwards, and our heat certs are going here and here, and this other one's going to wind up going in this guy right here. So you got, oh, it's not there. It's probably not going to stay, but all right. So I got my soldering iron set to about 240 degrees Celsius, about 10 degrees lower than what I print at. It's about what I tend to go with when I do these. I want just enough heat really to mold that plastic around this brass insert. Brass conducts heat very well, so we don't want to burn any of that plastic as this is going in. We don't want to cause it to harden beyond what it is now. We want it to be right about how it is in the print. So there we go. There's those. And this guy right here, this one's gonna be a little bit different. We can't really do it flat on the table, so we're gonna have to try to hold it in our hands while we do it and try to keep as flat as possible. Not overly difficult. Take your time. If your iron is too hot, so it's going to sink right in there quicker than you know what to do with, and possibly cause you some headaches. So, real quick. Another thing you could do too with a small part like this is get that heated up to about what you think it needs to be, and then give it a push down on a flat surface, just to finish it up. So there we go. So those three are in. Back to the manual we go. All right, heat inserts are there. Next thing we're doing is the BMG idler assembly. So lubricate bearings. Lubrication films required to ensure smooth operation and longevity. Refer to the BOM for lubrication or lubricant options. All right, so let's talk about that for a second. So there are a lot of lubrication options, but for the most part, everybody suggests PTFE type lubricant. Super Lube's very, very, very often used. I also have some clear gold plus that I have here. It's also PTFE. And then finally I have some Motorcraft PTFE lubricant. So I have 3 different types of PTF lubricants. I want to know what the difference was on them because I honestly did not know. So what I did is about 20 minutes ago is I took a smudge of each one and get that centered here. Smudge of each one and put them on a piece of paper to see what the qualities were. And here's what I can tell you. I can tell you that the Super Lube is the thickest of them all, stickiest of them all, if you will. The Motorcraft, the blue one here in the middle, seem to have the most wicking. So I don't know if that's because it has additional oils in it, but it did seem to spread out more than the others, and I also felt like it had a finer texture to it, not as much other things going on there. And then finally the clear gold on there, that one had the least amount of wicking. If you look at that, that's the clear gold over here. Over here. It also was the thickest. It had a lot of thickness to it, so I think that would stand up really well if you had something like a rail or something that you want to lubricate. You want to make sure it stayed on there. The Super Lube was right down the middle. And then finally the Motorcraft seems to have the most oil in there as well as the PTFE. So honestly, any of them will work, but I think on a bearings situation I'm going to use some of that blue stuff, some of that Motorcraft. Why not, right? So let's do that. Let's check what we got here. I need to get these parts out. I gotta find these parts. Where are these parts? These parts are probably in this box right here. Came with the kit. So looks like here we have our LDO Bondtech parts, and these look like they're official Bondtech BMG parts. So that's good. A little piece of Teflon tubing, PTFE tubing. Some more stuff in here. I don't know if we're gonna need this, but we'll leave it in there for now. For right now, all we really need is this. So we have lubricate films required. Let's idler. So we'll work on this idler gear. So we're going to need this rod right here. We're going to need one of those. Actually, we're going to need both of those. I'm going to go side by each, like that. And then we're going to need these guys the same. They should be, but they are. All right. We need one of these. And then we're also going to wind up needing this right here. So first things first, get a little lube on those. Paper towel, just to keep the work surface a little bit cleaner. I'm not worried about a small, tiny piece of paper towel getting in here. More of a concern on making sure that you have at least a thin layer of lubricant on this. that. I'm just gonna put a little bit, actually I'm just gonna use what's on my fingers right now, here. And then we're gonna slide these guys on. Roller bearings, like so. And then we're going to clean off our fingers. We don't really want lube on our gear here. We're going to slide that right onto there, like so. Zoom in on that a little bit right here. So basically we have a sandwich in here with our pin in the middle, 2 roller bearings inside there, and then of course our idler, or making this into an idler right there. So this piece is going to go into this piece, and it is going to go with the leg side up on this. You can tell by the cutout sort of that the gear is going to go over here, and if I'm not mistaken, if this is anything like the Voron Zero, we gotta give this a little of a push to kind of snap it in. Yep, yep, and that should spin pretty freely like that, and it does. Feel it just barely touching some plastic in there. But not enough to matter. Okay, so let's zoom out of that. So put that there, back up to this. So we have our like standoffs. I'm not sure exactly what they're calling them, so I'm gonna call them standoffs. And I found one. Where's number 2? Number 2 is still in the box. Number 2. All right, so we have our standoffs here. We got to put some heat certs in those. Grab a couple more of those. We need a total of 4, 1 on each side of these. There we go. And got a little. I'm gonna hit these real quick with just a little bit of sandpaper. Grab some smidge. Just gonna give them a quick hit like this. Quick little roundabout like this. We're pre-wearing it, if you will, right? See, all these parts will pretty much start to meld into each other over time. But the better, the more precise you print them, the less you have to. When all else fails, let's clean them up a little bit. There we go. All right, so we're gonna have to do 1. That. Another like this. And I'm going to basically get that in there, and then I'm going to do the flip over trick that we did on that other small part. So right now I'm not even applying pressure to that. I'm just going to flip it over and give it a push. There we go. We do the same over here. I'm going to push it in so it's locked into place. And get it about 3/4 of the way down. And then I'm not even going to apply pressure to it. Just going to heat it up, flip it over, give it a push. Hold it there. Not too shabby. Actually, see a little bit of a stick out there. Get a little bit more of a push, I think. The other difficult thing about little parts like this is you're really not working with a lot of plastic, so that plastic's going to bulge and melt a little bit when you're putting in a part like this. So this is a little bit different, at least for me. Fingers. All right, that one, and get this one started. No, if my print's a little bit off on these, or if they're off tight. Normally, these heat certs will just kind of pop into the start point and be nice and flush and ready to go. These ones are fighting with me a little bit. Stop short again, heat it up, push it around, pop over on the other side. Too much of a bulge there, I'm not happy with that. Hopefully I didn't mess that up too much. Not liking that. I think I have a spare or two. Yeah, I may have to use my spare. This one's kind of bulged. I'm not happy with that. So see right there, like I said, there's not a lot of plastic working with. When I push that down, it bulged it out and squatted it a little bit. So I'm not sure I'm going to use that. We'll set that aside for now. As odd and as funny as it may seem, these might be the hardest heat certs I've ever put in. It didn't bulge as much. Let me see if I can. Let me try to heat this up a little bit. Try to heat this up, and I'm going to try to, funny as it may sound, kind of squeeze that back out. Not even sure where that really goes in the end, so we'll see. It may or may not use that. It may or may not sand that before we use that. So we'll see where we wind up with those. All right. Component prep, short end of the shaft. So we're talking about the actual gear now. Check the short end of the shaft. That should, if it's longer than 3mm, shorten it to under 3mm. Designed for the printed jig included. Did not print that. I'm going to measure it. I'm going to see where it is, and then we'll check our bearings. So let's do that next. Where are we? Where is that? It is right here. All right. So what they're saying basically is the protrusion on this cannot be more than 3mm. It can be less than 3mm, just not more than 3mm. So loosen this guy up. And let's see what we're at here. 2.81. So I think that's less than 3mm, but let's go ahead and try that. Zero it out again. So on here, bring it up on this, there is a rib around the center and then the actual bearing, and it's like indented, which is not shown in the drawing, but that rib on that is actually out to where the teeth are, and this is indented, so it's actually 2.85 to the height of that rib. If I measure to that height, let's see what I got. 2.93, 2.87, which is 2.86. Now, if I measure out though, if I go to that center, the indented plastic, I'm at 3.49. So let's see where that leads us. Let's keep going with it the way it is, because if I follow based on the manual, what they're showing us here is the measurement from the tooth to the outside of that, which on mine is 2.87, so that should be fine. So we need some MR85 bearings next. And where are the MR85 bearings in the kit? I bet they're probably here in the box. Bearings in the box. That's not bearings. There we go. Bearings in the box. All right, so we're gonna need these bearings. Bearings must slip on the shaft. Easily allow the gear to self-center. Do not shim into position. Pressing the bearings in the shaft will damage them. Lightly sand the shaft if required. Remove the bearings from shaft after checking the fit and continue with the assembly. Okay, so what they want us to do is basically make sure these slide onto the shaft without much issue, which that one does, and that does. Here's the thing though, is that bearing, the shaft is protruding from the bearing a little bit, like tiny bit, like a shim amount. Bearing shaft will damage, like saying remove the bearing shaft. Let's see, self-centered, do not shim into position. All right, well, let's do this. How thick are the bearings? Bearings are 2.46. Number on these, MR85. I'm gonna assume those are correct, but who knows? We'll continue with the build. Probably gonna wind up lubricating this too, but let's continue forward here. We made it through there. This shows pressing one bearing into the center position on this plate, so let's do that. And it fits perfectly. Make ourselves a little fidget spinner if we wanted to, right? For the kids. I don't know, for the adults, who knows? Okay, so we got that, and now component prep. So we're going to use a piece of PTFE tube, 7mm in length, right here. So the kit came with PTF tube, and we're probably fine with the PTF tube the kit came with. Actually, it says Teflon tubing, which Teflon is PTFE. They're using brand name. But I like my blue Capricorn. So I can find, yeah, I got my blue Capricorn. I'm gonna use a section of blue Capricorn PTFE tubing just because I like it. Get a razor blade real quick. Get a nice sharp new one. And we need this to be 7 millimeters in length. So first things first, I'm going to cut this flush. I should probably print myself a PTFE tube cutter, but it's actually a pretty rare occasion that I'm cutting PTFE tubes, so who knows if I need one. Let's see, 7. We want exactly 7. I think if we're within the 100th, we should be good. That is a tiny piece. 7 millimeters. Huh. Okay. Why does it seem so small? Seems negligible to have it. All right, so I'm gonna hold this while I cut this. What could go wrong? Okay. Set that aside. Buy yourself a couple feet of Capricorn tubing and you'll have it for life. All right, so that right there is square and good. That's a junk piece. This we can close up. All right, set that aside. And we're going to be inserting this into another printed piece that we haven't touched yet. Let's see here. Where is that going? Okay, so that's going into this guy right here, into the bottom. It's sticking out. Oh, it's sticking out 7 millimeters. How long are you supposed to cut it? Come on, guys. Okay, well, let's see where this takes us. Zoom in on this one here. All right, so this is the guy that we're using, printed part, and it looks like about maybe 1.5 millimeters that this is actually going to go in there. So let's see how far we're sticking out. So we actually want to stick out 7 millimeters on this. So how far are we on that? How close are we, I should say? .33. All right, so we need to cut another piece about 1.7 longer. So 8.3. Do 8.3-ish. 8.3 in length. And honestly, I probably am going overkill on this. I'm doubting this matters as much as I'm making it matter. But why not? Okay. A little bit longer, 8.3, which should be what we need. Actually, we'll keep that handy. We'll put this in. So, and let's measure that again. Oop. We are at 6.9. Yeah, 6.9. Come on. 6.99. Oop, right there. Oh, 7. Yeah, it's bouncing. So that worked out pretty well. So we got our 7 protrusion on that. It's kind of weird. It didn't tell us what the overhaul length should be, but anyways, good enough. All right, 6 on that. So now we're going to be installing our gear. Looks like the gear is going to go into the backside and then is getting put on through this other piece. Okay, so it says right here the drive gear is mounted opposite of how it's usually mounted in Extruder. Make sure the grub screw has sufficient contact with the flat. All right, so let's pre-install our grub screw. Let's see what size grub screw we're using here. It's a large M4 grub screw. I don't know if it's that large. It doesn't look that large. Are these M2? M3. So single grub screw, M4. That's the right guy. Let's see if he's the right guy for the job. So these came with a little bit of ThreadLocker on them, so no need to add any. Yep, I need my M3. So that's going to be for something else. That M4. Go back in the box, grab one of these M3s. They gave us 3 of them. Whoa. Man, these look tiny. These feel too small. We'll see, I guess. And again, these came with a little bit of ThreadLocker on them as well. And it does fit. Go figure. Alright. So what they're telling us basically is when we assemble this, we want on this flat surface our grub screw to catch that, because or else it will just spin freely once we assemble. So let's try to put this together the right way. So this is going to go in like so. And there's nothing really holding it there. And then this, turn this so that flat section's pointed towards me, is actually going in like this. Loosen this up a little bit. And is that going to be flush against? I believe it is. That's going to fall out. Okay, let's make sure we get that there. Get that here. And then tighten this up. Okay. Okay, and that is lined up with the path. Let me zoom in here. So here's our filament path. Filament path right here, where our piece of PTFE tubing is going to go. Right, oh, come on. Right there. And it is lined up with our gear, or our I guess our gearing here to pull the filament through. So that's a big thing. So that's what you're looking for, is you want that to be lined right up. Now what I'm not sure about is why no one mentioned anything about lubrication on these plastic to plastic parts. So that's one of the good things about using a PTFE lubricant, is I'm going to use the Gold Plus on this because it was the thickest of the bunch. PTFE lubricant does not negatively impact plastics, whereas a lot of lubricants do, whether they weaken the plastic or wear the plastic in some regard. So I'm going to take that. I'm going to fully remove this. Take it right off. Take this off, and I'm going to apply some of this thicker PTFE tubing, lubrication, this clear gold. To the surfaces on that. Help with wear against plastic on plastic wear. Okay. And then I'm going to realign this, realign this. And we'll tighten this up again. All right, give that one more tighten. There we go. All right. Feel better about that. Maybe I'm wrong, but I feel better about it. In the end, it doesn't matter as long as I feel good. All right, so that's what we have. Drive gears mount opposite. How? Yep. We did that. Strat with flat. Yep. Done. All right, fans. Everybody needs some fans. So there are 3 different fans going in here, and in the kit that LDO provided, the fans are pre-wired with connectors on them. And it looks like we're putting these in a certain order. Left, center, and then right. It's probably for wiring purposes. So let me see if I can figure out if there is a rhyme or a reason as to how they expected us to put these in. Let's see here. These guys are identical. So looks like this is going to go in, slide straight in like so. And go tight on the bottom, give it a little kick sideways, and there. And it does spin freely, good. And then our center fan, let's see here, where they're not really showing where the wiring is going. I don't see the cutouts for the wiring on that either. Let's see, what I can't see is the missing screw hole. So I'm going to assume, since I can't see on the fan, there's only 3 screw holes. There's a screw hole here, here, and here, but not one here because that's where the wiring is. So I'm going to assume that this wiring is going to be on this right here because they don't show a hole there. So there's 3 there with no hole there. So that's what I'm going with. So this guy's going to get plopped down here. That. So we have 2 fans. It's not sitting. Oh, there we go. Flush. All right, and it is also spinning freely. It's good. All right, and then we have our other side fan. Now on this one, they're specifically telling us. Let's see here. They're telling us, let's see, orient the fan in such a way that the air is pushed into the cowling. Yep. Yep. Actually, into the cowling. Yeah. Yep. And then let's see here. You'll find a small arrows, the fan indicating airflow direction. Those are usually on the sides. I'll pull it back out, but those are on the sides of the boxing of the fan. So on, the really thin sides on it, there'll be little arrows that point that way. The other way of telling is usually your gating or your protection on the fan, your motor side of it is the side that it blows towards. So yeah. Another way you can, I will take this out. Let me just do this for you guys. Let me pull this back out real quick, just so we can go over that a little bit, because I guess that's kind of important, especially if you're not familiar. Get this out. There we go. All right. So, yeah, no arrows on this. Well, that's fun. That's fun. All right, so 2 things. One is arrow would be normally there would be an arrow pointing here in the direction. that it blows in, which there are none on this one that I can see. Secondly, you'll see that there's usually an arrow on direction. So I can almost make out an arrow here. The direction is this way. And if you look at the fans, the props themselves on the fans, you can see which way they're going to scoop air. So basically, these are scooping air this way. So they're pulling it and pushing it back towards there. So I know the direction is that way. If these fins were positioned the opposite direction, or if this was turning the opposite direction and spin, it'd be pushing air this way. So if you don't have arrows showing you which way they are on, you know, your cowling or your framing or fan, you can look for an arrow that tells you which way it's going to spin, and then look at the direction of your fins, and if those fins are scooping air and pushing it which direction, which will also tell you. So put that back in now. Hopefully. Goes in there pretty tight. There we go. Oh, it's a scary sound when you're working on plastic. All right, so there's that one. All right, and that is right there. And then I'm also going to mention this right here. Let's do a zoom in on these wires. I don't see a mention of it. Oh yeah, they do. So you want to make sure that your wires aren't going to be stuck behind your other fan. So I'm going to go ahead and I'm going to try to work these backwards a little bit, which I probably should have done when I had this out just a second ago, but that should work out with that. So basically what you want to do is make sure your fans, there we go, I pulled them up, aren't stuck towards your other fan. You want everything to spin freely, so these are pulled away or out of that little notch there that can hold them, because your other fan's gonna be right up against that. So let's look real quick, and they tell us right here, insert angle, insert fan, clip into place. Let's see here. Orient the fans such a way that you can guide the wires in the highlighted path. Okay. And that's what we'll wind up doing when we get to that point. So we're gonna put this fan in now. Oh, let's see here. This one needs to go in. Well, that's odd. This one needs to go in like so, which means we're going to have to pull these wires this way. So these wires are gonna go underneath that. And then that's why they have the additional cutout here on this side. And they say do it at an angle. There we go. Okay. So let me get to the bottom, push over there. All right. So lots of fans in a little space. We have both of our part cooling fans on here, as well as our hot end cooling fan on here. And I think we're good. We're good there. Now, where are all these other wires going to route eventually? I don't know yet, but I'm sure we'll find out soon. All right. Really don't like this wire hanging about. Did they make it so? Is there enough room? You know what? Maybe I underestimated. Maybe I underestimated the smart people that designed the Voron stuff, and they actually left enough room in here for these wires to play nice with this fan. So let's check that real quick. So I'm gonna see if I can put these back in the way they were. I'm gonna struggle for a second here. Probably should just get some tweezers or something, but get these down and do one at a time, maybe. One at a time. That. All right, now let's see if we wind up with enough room to route those. I'm willing to bet you those guys are smart. I tell you, but you already know it. Then we're going to push that in, and what I'm doing now is I'm just making sure I'm not actually pulling these the Hotend fan wire. I want to make sure I'm not causing that to get pulled. It's actually going to get locked into place, and yeah, kudos to them. That seems to have worked pretty well. All right, there we go. Not too shabby. All right, let's see where we're at. All right, axle fan wiring path, blower fan, yes, we put that in. Wiring guides, highlighted path, so that's that blower fan. They didn't show us where the wiring path was for the other blower fan, so I was ignored. Okay, yeah, we're good there. All right, my mistake. Definitely do it the way I did it the second time. So the Hotend, fun parts. All right, let's get right into that. So on the Hotend parts here, we're going to be doing. They're showing it with just a standard E3D, or no, actually Dragonfly. I don't know. They got something on there. However, we're going to be using our REVO Voron, which might be the lightest print head available, I guess readily available. All right, and what does it come with? Let's look what it comes with. All right, so you got some cool E3D stickers in here. I've got some wiring, some extension wiring. I've got another piece of PTFE tubing. What I don't have are any screws. I don't think. Nope. Got a little sticker here telling me I should order some more nozzles. I have other nozzles, so I'm not going to do that. It's thought though. Put those stickers back there, put that back there. Temporarily throw that back there, and let's figure out what we're going to do here. So they're using two M2.5 by 6s. We're going to wind up using 3 M2.5 by 6s. And where do I have M2.5 by 6s? 3s, 2.5 by 6. M2s. Make sure it's not M2 that goes into this. I'm not even sure what these threads are. Okay, so that's not an M2. I don't think it's an M3. Seems a little beefy for that. But I could be completely wrong. It is an M3. All right. All right, so we can use some M3s. It says M3 by 6s. So we need some M3 by 6s. So we're going to use 4 of them on this. 4 M3 by 6s. So this Voron REVO VORON, actually 3, sorry, was made in conjunction with the Voron team, from what I understand. And it was a decent amount of effort put together to come up with something that was as perfect as possible for the Voron printers. So this is pretty exciting. All right, so I'm going to get one screw started. That, my second screw started. That, and number 3. Boom. 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 Nice. And just so everything's not flopping around, let's go ahead and put that super cool REVO nozzle in. It's about 2 millimeters lower than the rest of it there. But there you go. There's our REVO inside of our mini afterburner. Pretty slick looking. All right. So what are they saying here that we can kind of ignore because we didn't use? Heat sensor. We don't show the heater and temperature sensor in the drawing. Install them prior to assembling tool head. Done. Other hot ends are showing the assembly using a dragon. Okay, so that's a dragon. Tool heads hot head include release files assembled in similar manner. Ball driver for the left screw. Wasn't that difficult. Check orientation. Heater block must point towards the back, and we don't have to look at that either because it's a really nice hot end. So okay, so our MR85 bearing needs to go in there, and then some M3 by 35. So let's jump back onto this. So our bearing first. I don't want to crush it. Let's use this. So this should actually, if I'm correct, push in. Sorry, these wires out of my way. This should actually push directly in to the piece with some force. I think we got it. Make sure it still spins freely. Yes, it does, and it is nice and tight in there. Okay, there we go. Now you can soak these bearings if you want to in some light oil. I don't think you have to, but you can. They're sealed bearings from what I can tell, so you can do it if you want to. You don't have to. And then we need some 35s, so 335s. So our 335s, just so everybody sees it, are going in there. 1, 2, 3. And we're talking about these guys right here. The bearing just went in. Those all slide right in there like that. And back to this. Where are we at now? We are, we're starting to work on the extruder. That's where the fun starts here. In case we weren't having fun yet. I was having fun. Maybe you weren't. All right, so let's work on alignment here. See if we can figure this out. All right. So we're gonna do this. I'm gonna lay this flat, and I'm gonna try to work backwards. So I think this is kind of tricky. I'm gonna make it twice as tricky for me because I love to suffer. so we have our drive slash extruder gear here. That's going to work off of the main big gear, and this is going to slide over a screw head. And which screw head is this sliding over is my question. This is sliding over, which way is this going? This is going with the bevel facing outwards, so like this, and it is going on this side. So pretty much the only way it can go and do those two things is this way. It's a little tight. It's so tight. A little tight. Let me too much. Let's see if I can clean that up a little bit. It's gonna use another M3x35 and just run it through there real quick. This should spin pretty freely. I mean, it doesn't need to spin super free, but it's not meant to be threaded, so let's go ahead and run this all the way through, and I'm gonna let bottom out, and I'm gonna keep going. I'm gonna run it backwards and run it forwards, run it backwards, run it forwards. Now I'm gonna try to just push it out. There we go. And everything that's a little bit too tight, it's a good way to do it. So basically what I did is I ran a screw in and out of it a few times, and then pushed it through backwards to loosen it up. So now I should be able to get over this. It still is going to be pretty tight, but it will go. There we go. And that's going to sit like so. And then they want us to put our notch. That's going to face upwards like that. So we have this on that, that like that. All right, back to the screen. So we just put in the gear, we just put in the latch, the catch right here, and then they're showing it where everything's moving freely and that latch is staying in place, and then we're going to leave it where it is right now. Okay, so then we're going to put the other two screws in, which is fine. Then we're going to take our top portion that we put through with the big gear, and we're going to slide that in place. All right, so at this point we are going to be placing this, and I'm going to move this over. I don't want that to bind up yet. Now how am I supposed to, oh, I see. Let me take that screw back out. Doy. Right, take that screw back out. Well, how are we finagling that? Let's see here. Move the screws forward. Yeah, got you there. Until they sit flush with the printer part. Yeah. Push the drive gear all the way to the back so screws are forward. All the way to the back. All the way to the back to help screws forward until they sit flush with the printer. Tilt the part slightly backwards. The PTFE tube falls out. Alright, so you know what? Just for giggles, I'm going to try to put, let's see here. I'm going to try to put my tube into here first, because it actually sits in there, and then tilt this back like they say, push this forward, and I think that's what we want. I need a piece of filament. I'll be right back. Piece of filament. All right, so got a piece of some handy dandy Amazon Basics filament. And let's see if our path is clear here. Let's actually take this out. Gear is catching, so oh. Seems like we're pushing awful hard to make this work. Let's see, that gear, pop that out, pull that back out, cut this back. A little bit of a sharp end on that. Let's make sure our gear's out of the way. There we go. And I'm catching on something. All right. Not a bad thing, just a thing. All right, what am I catching on? Because I'm not even making it. Oh, there we are. All right, so looks like I'm making it to and through our path right here, but it's really tight. It's tighter than it should be. That could be a print tolerance thing. See it right there at the edge. So I'm going to work that a little bit. So this should be a really, I mean, it should be tight to the point where there shouldn't be a lot of tolerance in that filament on the path. But at the same time, it needs to be able to work through there pretty smoothly. So I'm going to try to get it through at least to the point where, and plus I'm trying to push something as opposed to pull something. It's always more difficult, but I'm going to try to get through to the point where I can grab it. No, I think it's too tight. What do I have? Let's see. If I have small, looking just for a small Allen wrench that is pretty small, just enough to, there we go, just enough to get in there and kind of do a quick ream. Don't want to overly change things. I just want them to be a little bit looser, not too loose. There we go. Okay, so we got that through. All right, so let me grab that. I'm gonna work this back and forth. Whatever you do, don't put any lubrication in here. If you put lubrication in this, you're never going to, well, can't say never, but you're going to have a heck of a time printing until that lubrication, that whatever that material was that you put in there, works its way completely out. And that could be a long time. And until that happens, your prints are probably not going to have good layer bonding. You're going to have adhesion issues. You're going to have all the issues. So you want it tight. but not too tight. And you don't want to add lubrication. All right. I'm going to try it one more time here. Still tight. Oh, I'm catching on that tooth too. I'm actually catching on, wind this out, sorry about that. Actual extruder gears grabbed me too, which is a good thing, right? But all right, I think we're getting there. All right, I'm gonna call that good. I think it is good. And grab a fresh piece of plastic, a piece of ABS, and let's see if we can get this back into play. So we're going to basically put that in like that. All right, and then should undo that latch, make sure it's free, and here's kind of catching me on. Still catching on something at this point, so let's push it as far as we can and see where we're at. So we are at the other side where the PTFE tube is. So what I suggest you do, I've done this before, and I'm gonna have difficulty doing it at this point, but I might have to actually take out my hot end. But actually, if I use an X-Acto knife, if you put a small chamfer, if you do a small chamfer on your PTFE tube where it goes into your hot end, so basically try to cut a little, like a 45 in there. Make sure you don't leave any of that material in the tube, because the whole purpose of using PTFE tubing is that it does not melt under normal circumstances. So it could screw up your prints. But if you put a little chamfer on that, you'll lessen the chances of having issues down the road. Let's do this. Like I said before, don't leave any little particles of that tube where they can get caught. All right, so let's pull that back out. This guy needs to go back in. You need to be there for when we put this together. Then we're going to that all together like that, and then let's give this a try. Still get caught up there at the very end. Right when we're going in that tube. Okay, so I'm going to disassemble this a little bit. I'm going to work backwards a little bit here. Take this off. Take this out. These screws fall where they may. I'm going to unscrew this. What's happening is our alignment's pretty decent, but it's not perfect. And honestly, perfection is pretty hard to get. So we're going to try to push this out. We're going to try to give ourselves a little bit of more of a fighting chance here. I'm going to put a little bit of a chamfer on this, like I mentioned before. Over time, this tend to happen to the tube anyhow, because even though this plastic may be a little bit harder than what you print with normally and a little bit more heat tolerant, eventually, just because of wear, it's like water on stone, it will wear, and this will happen naturally. But we'll give it a little bit of a hand by doing it ourselves. All right, so I'm going to push that back into place a little bit, and then we're going to take our Voron piece and put that back in. See if we can get this line back up. First screw, second screw, third screw. Go back through and give another quarter turn or so. And then we're going to push our PTFE tube a little bit and pull that back out. And without any screws in here, actually, just in case it does work perfectly, let's at least get this screw in. Stop jumping out. And then push this back. Hold that while we're doing this. So move that over that. Okay. So everything feels to be in place properly now. Let's give this another dry run here. All right, so there's that. And we're through. Oh, through all the way. But plastic isn't so great. There we go. All right, so now we have access both ways. Our path is a little bit tighter than I'd like to have it. But that will change. We can run some slightly abrasive material through there, and that will change up pretty quick. All right, awesome. Back to the screen. All right, so that happened, and that happened. Roger. All right, so those two screws are going back into place. Screw number here. And screw over here. Yes. There we go. All right, so those two are back in place, and they're holding that back panel on. So these are going to be like this. Well, they're actually not holding the back panel on, they're just hanging out there. So we're going through that bearing right there. And at this point, we still haven't attached that to that, but whatever. All right, so our back plates are here, push screws back. Start screws all the way. Yes, they're there, good. Man, real simple drive on that. That right there is probably one of the simpler drives. It's a single-sided extrusion drive on that, but very simple. Very simple. I like that. I like simple. All right, so let's see here. We are now going to put Mr. Duck in. I call this guy over here the duck, the goose, whatever you want to call him. And then we're going to put our BMG thumb screw, which is going to attach that latch to its final spot. And then what do we need for screws? We got 2 M3 by 30s. So we'll grab those, and then we will get this together. All right, M3 by 30s, 2 of those. I need 2 of those guys there. And then our duck is going right here. And those 2 screws are going to screw. We go a little string on that. Let me clean him up a little bit. So, quick tip: if you do clean up parts, you know, just a little bit like that, you don't want to actually deform or change the part much. But if you got a little bit of white powder on there after you're done, or if it looks a little grainy, if you got a heat gun or reflow or anything where you can get up to about temperature of your plastic. You zoom in on that. Little tip. So that's what that looks like right now. I'm just going to hit that quickly with some hot air as soon as it gets up to temperature. Actually need a little bit more temperature. So basically what it's going to do is it's going to melt the plastic just a smidgen. And when it does that, it'll come back to the same original sheen and color that you had before you sanded it. So you kind of fill in those micro holes that you made when you were sanding, those micro scratches, I should say. So you're not melting it, you're not getting it hot enough to melt it, you're just heating it up to get rid of those abrasions. So there you go. Nice part. Huh? All right, so holding that like that. He's going like this. And then our 2 screws, one's going through him. And then tightened up. And again, we got plastic on plastic right here, so I'm gonna put a little PTFE grease on this again, or lube. Probably don't need it here. Oh, I don't want that one. I want the clear gold. Probably don't need it here. This isn't, I mean, other than when you change plastics, you're not really going to be moving this much, but you'd consider it, and I do it now versus later, because later is going to be meaning disassembly. All right, so let's tighten that up. And then on these, because basically this is going to suck those pieces all together, if you go too tight on this, it's going to be unbearably hard to close. So be careful with that. So you want that to have a little bit of, you know, play, a little bit of give, whatever you want to call it, but still be screwed in. Yep. I'm actually gonna actually over tighten that a little bit. I'll tell you why in a second. Tighten it to the point where it's as tight as I really want it, ever, and then I'm going to pick about a quarter turn off. Be good. All right, so there's that, and then our second screw is going through here, and basically that's our latch screw. That is what that's going to latch onto when it's functional. And that seems too long. Why does that seem longer? I'll remeasure the screw real quick. It's supposed to be an M3 by 30, and it feels like it's going further than it should. Because it's a 35. There we go. One of my 35s fell at the back when I was doing it, so there we go. And that one can be pretty tight. Basically your latch. That's where you're going to wind up when latch down. Too tight, you're just going to jam up plastic, so I'm going to loosen that up just a little bit. There we go. All right, so it's a working latch. All right, so next up we have our BMG thumb screw that came in a kit. It's on the side here. And it came with 2 springs. Not quite sure why 2 springs. It's probably different tension. Yep, different tension. I got a high tension spring and a lower tension spring. So I'm going to start off with low tension spring and put that on like so, and then our washer here, and then this should tie in through our front piece here and into the piece on the inside. So basically when we clamp this shut, you didn't see that, so basically this right here, when you, this will move in because it's clamping. See, watch, see how that moves inwards when that happens? It's clamping on the filament, and then we're clamped shut right there. So if we put a piece of filament in this right now, I'll have to grab another quick piece. PLA. Let's grab some PLA. All right, so if you grab a piece of filament, mind you, the nozzle's still off. But if you take a piece of filament and we got a clean end on it. So right there, filament's in it, it's coming through all the way. Once, you know, and I can pull that back out and push it back around, do whatever I want there. And actually it's a little too tight because it's still catching. All right, so anyways, when you clamp that close, what that does is really grab onto that filament all the way. So at this point, that filament's not moving without that gear moving as well. Whereas when it's unclamped, I hold that gear, I can pull it out. So there you go. Clamp that closed for now. And just for safekeeping, I'm going to put my nozzle back on here. And let's see where that puts us. Should be close to being done with this guy. Keep that second spring aside. All right, so where are we here? Okay, so now direct feed extruder. Check for binding, turn the gear, and check if there's any binding or snags. Assemble 2 head, inspect if required. So there are no snags. It spins freely. And we should be good there. All right, good. All right. Where are we going to be? We're going to be doing that. We're going to do that. Okay, there we go. All right, so with that. All right, so with that, I'm gonna call that done for this particular video. I'm gonna have a part 2 to come along with that, but we pretty much got this all assembled. We're going to put this on the printer. We're gonna basically get our stepper motor on there, and I will see you next time. Hit like, hit subscribe if you're interested, and I'll see you soon.